Hello, everyone, and welcome to another topic in chemistry as we continue to learn more about how we use chemistry and math and the mole all together. If you are taking these notes on the day that it is assigned, it's February 3rd. Otherwise, fill in whatever date it is. Set up your focus notes. Our topic is empirical and molecular formulas. Our essential question is, how do I use lab data to determine the empirical and molecular formulas of a compound? That's our focus for today. Go ahead and get your notes set up and let's get into it. So you might be thinking, well, wait a second, we already know how to write formulas. You look at the name and you write the formula. Well, of course, that only works if you're given the name. And then also, you might know the name, like what the elements are, but you might not know their oxidation numbers, or there might not be oxidation numbers, right? Because sometimes there could be more than one options. For example, iron has a couple different options. Copper has a different couple options. There's dichromate ion and there's chromate ion. They're both chromium and oxygen. So there's more than one option sometimes, especially with covalent compounds. You maybe remember in biology, there's sucrose and fructose and glucose, all these different versions of sugars that are carbon and hydrogen and oxygen, but at different kind of ratios. So just knowing the elements doesn't always mean we can write the formula. So another example would be carbon monoxide and carbon dioxide. Like, how do we know which one it is based on what's around us? So that's what we're going to learn how to do today, is how do we write the formula when we don't just have the name or we don't know exactly what we're starting with? We need more information. We're going to use lab data to get the correct formula. So I think you'll start to see that this looks a little bit more like what chemists need to do rather than here's the name, here what's the formula. Probably not super practical as a career chemist. So what might a career chemist do to get the formula for something? Well, there's two types of formulas. Empirical, which is the lowest whole number mole ratio between elements in that compound. So for example, CH4. This is a 1:4 ratio, and it turns out that the ratio happens to be measured in moles. So really, there's 1 mole of carbon for every 4 moles of hydrogen to create this compound, which happens to be methane, a type of fuel. So lowest whole number mole ratio between elements. That's an empirical formula. So moles, huh? Guess what time it is? What competition is Avogadro trying to enter? Oh, it's such a big deal. He really wants to be in the Olympics. Good luck, Avogadro. I don't know what event he'll do. You'll have to think of something that involves moles. All right. Back to this, two types of formulas, empirical formula and this thing called molecular formula. That was from the topic for today. Okay, so what's the difference between molecular? It's a multiple of the empirical formula. So empirical is the lowest whole number mole ratio. So if you times all of this by 4, that'd be a molecular formula. If you times all of this by 8, that's a molecular formula. Lots of organic compounds. So going back to that sugar, so like fructose, sucrose, glucose, those are molecular formulas of each other. So for example, if I multiply all of this times 2, I get C2H8. If I multiply all of this by 8, I get CH832. So the point is that they're always going to be related to each other. You need the empirical formula to get to the molecular formula, or you'll see the relationship between them, which is one of the things I'll show you today. Okay, go ahead and do a level 1 question. Pause the video if you need to take a little break, or go write your Costa questions from the guide on Schoology. But remember, it's something that comes right from the notes, a definition, a list, complete the sentence, something that comes right from the notes. Come on back when you're ready. All right, so let's talk about empirical formulas first. This is what a problem would look like. Here's the data we would have. What is the empirical formula? Meaning I want the lowest whole number mole ratios between nitrogen and oxygen. Now, this is going to look fake, but I promise you it's not. This is pre-AP Chem, so I'm going to ask you to trust me. The more chemistry you take, you'll find out that we have super amazing instrumentation, like machines, that if I take a sample that I find from somewhere, I can put it in that machine, and because that machine has been programmed to do really amazing things, you can get the percent of that compound, what elements are in it. So again, this sounds like I'm just hand waving, but this is a real thing. So I'm going to ask you to trust me. The more chemistry you take, the more you'll learn about those really fancy instruments or machines that can do stuff like this. But this is a real thing. So if I find a random chemical at a crime scene or in the basement of some people that are getting sick or whatever, I can take that sample, put it in a chemistry instrument, they're called, instrumentation, or a machine that will tell me that it happens to be 25.9% nitrogen and 74.1% oxygen. So I'm given that information. So that's my lab data. I know there's nitrogen and oxygen. I know kind of the ratio out of 100 of how much there is, but I want that lowest whole number mole ratio. So what I'm going to do is basically I'm going to take that percent, and because percent is always out of 100, I'm just going to call this, instead of percent, grams. Again, that's not cheating because that's what percent means. So if I have 25.9% of something, I could say that's 25.9 grams out of 100. So now I've got a unit that is related to moles that I can actually do something with. And then we're going to do some math tricks to get whole numbers. Let's do it. So again, do this problem with me. Don't just watch it. So in your notes or on a piece of scratch paper, let's figure this out. What is the empirical formula for a compound that is 25.9% nitrogen and 74.1% oxygen? So the first thing, you just call percent grams. It's not cheating because percent means there's that many grams out of 100 grams. Well, let's pretend we have 100 grams then. 74.1 grams of oxygen, 25.9 grams of nitrogen. Now I'm trying to get the lowest whole number mole ratio. So my first step is to go now from grams to moles. Well, that's molar mass, right? So I set that up. 74.1 grams of oxygen, and I go from grams of oxygen to moles of oxygen. This is the number from the periodic table. Grams will cancel, and then I'll be able to get 4 point blah, blah, blah. I don't worry about a sig figs yet because this is not a chemistry answer yet. This is just a math ratio, moles of oxygen. I do the same thing with my others. So 25.9 grams of nitrogen. The molar mass of nitrogen is 14.01 grams for every 1 mole. Grams will cancel. Now I get this many, big number dump, moles of nitrogen. Again, these are just math ratios right now. They're not science answers. Now, technically, this is my mole ratio, but empirical formula is lowest whole number mole ratio. So I'm going to do some math tricks. I need whole numbers, but I have to keep this ratio the same math ratio it is right now. So one thing I could do, one math trick, is I could divide both of these by the smaller number. If I do that, so if I divide both of them by the smaller number of moles, I'll get this as a whole number for sure, 1 mole. And then if I divide this, I'll get some answer. Okay. So now, once again, I've got mole ratios. They're the same ratios as these numbers, but I'm trying to get whole numbers. So I'm doing math tricks. Dividing both numbers by the smaller will give me 1 whole number, but then I still don't have a whole number for my other. But now another math trick I could do would just be multiples. If I just keep multiplying these numbers by 2 or by 3 or by 9 or by 11, eventually you'll get a whole number. Well, you might notice that, wait a second, always start with the lowest possible. So always start with 2. But whatever you do to one number, you have to do to the other number to keep the same ratio. So if I multiply this times 2, I get a number that's close enough to 5 that I can round it. And by close enough to round, the rule is 0.0 can round down or 0.9 can round up. So when I multiply this, I get a number that's close enough to round down to 5. And then if I multiply this by 2, I also have to multiply this by 2, but then that still is a whole number. Now I've got 2. So 2 moles of nitrogen, 5 moles of oxygen. That is my lowest, because a 2 and a 5 can't reduce, whole number, 2 and 5 is whole, mole ratio. And then I can write my formula, N2O5, because it's 2 moles of N, 5 moles of oxygen, but those are now your subscripts. So we're learning more about formulas. Mole ratio between the elements in the compound. Empirical formula because it's the lowest whole number mole ratio. All right, look at all that we just did. All that chemistry, all that math to get something new, a new piece of information. Now we know the identity of this unknown compound. All right, go ahead and do a level 2 question. Something about maybe you could summarize these steps or draw a picture to help you remember the steps of calculating empirical formula. You probably can't just make up a new number because they have to be real data so that they come to a real answer. So you might not want to make up your own, but you could explain or compare or contrast. That might be good. Compare empirical and molecular definitions. That would work. Okay, write your own level 2 question. Take a break. Come back when you're ready. Here we go. Guess what? Remember, we're still dealing with moles, so we got to keep doing some mole jokes. Why did Avogadro go to the zoo? He loves to see the animals, all the different animals. He just loves them. Oh, Avogadro. Okay. I actually am going to assign your summary right now. So you would put this on an output page so you have plenty of room next to your notes. But this is what I want you to do for your summary today. I want you to fill in this critter diagram to summarize the steps of empirical formula. It's called a critter diagram because it kind of looks like an animal: head, legs, tail, that kind of thing. It's really just a concept map, but critter diagram is a more fun term. So what you're going to do is you're going to think about, what do I need to know that leads to something else, that leads to something else, that leads to, you can give you a hint. Empirical formula is what we're trying to find. What else do I have to know? Which leads to this, which leads to this. So from the notes we just took, the steps of the example we just did, fill in these blanks to summarize finding empirical formula. So pause the video if you need to. You could try it right now, or you could rewind and come back to it at the end of our notes. So we're not done with our notes. We're only about 2/3 done, but this is what I want you to do for your summary today. Okay, now remember, there were two types of formulas. Empirical is what we just learned how to do: lowest whole number mole ratio. But then there's also that molecular formula. So what we need to do is we need to find the empirical formula, and then we need to multiply it by something to get the molecular formula. Okay, we're still dealing with moles, remember? So here we go. Where does Avogadro stay when he goes on vacation? Where would he stay when he goes on vacation? He stays at a motel. Unless he's feeling fancy, maybe he would stay at the Mole-a-Day Inn. Oh, look at that Avogadro. He's having a good time. Safely staying at a motel or the Mole-a-Day Inn. Okay, so we're still dealing with moles, but now we're going to talk about molecular formulas. Here's what an example would look like. What is the molecular formula of a compound that contains 43.6% phosphorus, 56.36% oxygen? Oh, and look, there's an extra piece of information. I know that this molecular formula has a molar mass of 284.00 grams per mole. You need this extra piece of information, otherwise we cannot find molecular formula. So just know that if you're only given percent, that's empirical formula. If you're given percent or grams and molar mass, that's how you will be able to find molecular formula. Let's try it out. The first thing you got to do is find the empirical formula. Oh man, we got to go through all those same steps. Gives us a chance to review. Because remember, the definition of molecular formula is a multiple of the empirical. So first you find empirical, and then we find the ratio between the given molar mass and the empirical molar mass. So that's going to be the extra one little step to solve this question. Let's do it together. Here's all that same information, the percents and the molar mass of the molecular formula. We start by finding the lowest whole number mole ratio between phosphorus and oxygen. So once again, we're going to take our percent, call it grams. It's not cheating because percent means out of 100. So let's pretend we have 100. Now we've got grams. I'm trying to get mole ratio, so I have to go from grams to moles. So this is my given grams of phosphorus. This is the molar mass of phosphorus, 30.97 grams for every 1 mole. I get an answer on my calculator. I don't have to worry about rounding it yet because this is just a math answer. It's not my chemistry answer yet. I do the same thing with the other given, 56.36 grams of oxygen. The molar mass of oxygen is 16 grams. For every 1 mole, grams cancels. This gives me the moles of oxygen. Well, now I have my mole ratio, but it's not whole numbers. So now I do my math tricks. Divide all of the chemicals, now there's only 2, but as many as there would be by the smallest number. Because then for sure you'll get 1 whole number. But whatever you do to 1, you have to do to all of the others so that the ratio stays the same. So I divide by the smallest. I get an answer on my calculator. This happens to look similar to our last one. That won't always be the case. That just happened to be the 2 examples I picked. So now it's not a whole number yet, but I can now do a multiple to get a whole number. You always want the lowest whole number. So we're going to start by multiplying 2, see if that works. If not, we would try 3, then we try 4, then 5, then 6, whatever, high as we need to until we get a whole number. But if I multiply this by 2, I get a number that is 5.0 something, so I can round it to 5. So remember, the rounding rule is 0.0 rounds down, 0.9 rounds up. If it was 5.11, nope, not close enough to round. 4.87, nope, not close enough to round. So it has to be like in this example, it had to be 5.0 something to say, oh, yeah, that's close enough to 5 to call it a whole number in math. But then whatever you do to one chemical, you have to do to all the other chemicals in this compound to keep the ratio the same. So I also times this by 2, still a whole number. So once again, like I said, I realize this looks very similar to our last one, but it's a different chemical, different numbers, same process. 2 moles of P for every 5 moles of oxygen. Lowest whole number mole ratio between the elements. So my empirical formula is P2O5. But that's not our final answer this time because it wants the molecular formula. So this ratio is true, but it doesn't match my final answer yet. So remember, the ratio between the molecular molar mass and the empirical molar mass, and it's always this order because we always know the molecular formula will be the higher molar mass because remember, the definition of molecular formula is a multiple of the empirical formula. So it's always the bigger mass over the smaller mass, molecular over empirical. So I need the empirical molar mass. 2 phosphoruses plus 5 oxygens. Phosphorus is 30.97 times 2. Oxygen is 16 times 5. So I get that all added up. This will be the molar mass of the empirical formula to get my ratio. So 141.94 grams per mole. And then I'm going to take the molecular mass, which was given, divided by the empirical. So this gives me the ratio between these two chemicals. Because again, the definition of molecular formula is that it's some multiple of this. And I can find that multiple, that ratio, by dividing the 2 molar masses. This works out to be about 2, and it will always work out to be about a whole number. If it's not, that means you did one of these masses wrong, or maybe you have the wrong one on the top or the bottom. But it always, because again, this is real data. These are real chemicals, so you're not going to end up with numbers that don't make sense. If you're doing this in a lab situation, you might get weird numbers, but then you would discuss why they're not perfect. That's what we're going to talk about next time. For now, though, let's finish this problem. The ratio between the molecular and the empirical is a 2 ratio. So I take everything in the empirical formula times 2. So it will be P2 times 2, O5 times 2. So P2 times 2 is 4, O5 times 2 is 10. So the molecular formula is P4O10. How could you check your work? Add up this molar mass. 30.97 times 4. 16 times 10, add it up. It better be equal to 284.00. Otherwise, you would know you made a mistake somewhere. So different ways you can kind of check your work. You can see that, yes, I realize this is lots of little steps of math and chemistry, but it gives you one glorious, real piece of practical information. You know the identity of that compound that you found in a lab situation or a crime scene or some contaminant somewhere. Practical use of mole chemistry in molecular and empirical formulas. All right, go and do a level 3 kind of question. Predict a situation where you would need to find the molecular formula. Make up a scenario. How cool would that be? So pause the video, finish your level 3 question, come on back when you're ready. And we should probably do one more of these to finish off our notes. What is Avogadro's favorite game show? And I'm pretty sure this is still on, or at least maybe there was reruns at some point. It's a little bit old, but they've done different versions of it. What is Avogadro's favorite game show? Who wants to be a millionaire? Yay! All right, that brings us to the end of the 4th day of this unit. Here's your to-do list. Go back and finish any Costa questions to review today's notes. And then remember that critter diagram was your summary for today. It summarizes the steps of finding empirical formula. Then you are now able to finish that mole practice assignment that I assigned on January 29th. You can do all of the problems. And remember, the answers are given. So you can you just have to match them, which will help you check your work and check sig figs. If you are watching this video when it was originally assigned, this mole practice is due on February 5th. So just make sure that you're getting that done. There are some unit practice problems. They are in Schoology in the week 7 folder. The answers are posted so you can check your work, get immediate feedback, see if it's making sense. And as always, I appreciate your attention and your learning with me, and I'll see you at our next Zoom. Bye.